Algebra 1 Common Core, Unit 8, Section 1, Solving Factorable Quadratics. So before we get into factorable quadratics, I want to just talk about quadratic structure a little bit. If you want to follow along with your graphing calculator, if you type in your y equals screen, x squared minus 2x minus 8, you're going to get this graph when you graph it and this table when you take a look at the table. A couple of things about quadratics we've already talked about. We've talked about roots where the graph crosses the x-axis. That would be these 2 points here. They're called roots. They're also referred to as zeros. In this particular example, it looks like -2 and 4, and you can see that here and here. And what you look for in the table is you look for the y values of 0, because a y value of 0 means it's on the x-axis. And we also talked about the vertex, which in this case is the point 1, -9. And on the table, you're looking for that point that doesn't repeat. It's where the pattern kind of turns around and changes. The axis of symmetry would be x equals 1, the x value of the vertex. That's that vertical line right down the middle. But what we're really focused on today is the roots. We're going to talk a lot about that. And the way we're going to see that is through factoring. That's what we're talking about here. So if I take this y equals x squared minus 2x minus 8, and the first thing we want to do is set equal to 0. And the way we do that is we replace the y with 0. So instead of y equals x squared minus 2x minus 8, make it 0 equals x squared minus 2x minus 8. And then you go about factoring. And, let me go down here and I'll talk a little bit about factoring, then I'll come back. The way that I like to do factoring is with a G, 2, 3, 4 approach. And what that means is you start with the GCF. Is there a GCF? Always look for that first. If it's not, then you go to the 2, 3, 4. Now, first of all, this is all working under the assumption that it is factorable. And this is a lesson on factoring, so yeah, it's going to be today. But you will get to the point where you have some things that are not factorable. And if it's not factorable, then we have other methods other than this. But let's pretend it is factorable. Look for the GCF first. After that, if it's 2 terms, it's a dots, 3 terms, trinomial, 4 terms, grouping. Trinomial is the tricky one because that goes into 2 different paths. It could go into an AM basic factoring or AC advanced factoring. So you might have to do a little bit of that. But again, this is all review. You can go back and look at the previous videos on how to do each of these styles if you're really not sure. Because that's really an important skill you're going to need for this. That's really 90% of these questions is factoring. So after you set it equal to 0, you factor. And in this case, there's no GCF, there's 3 terms, so this is a trinomial. And basic trinomial factoring here, because there's no number in front of x squared, it's just what adds to -2, multiplies to -8. You're welcome to pause the video and try this yourself at any time, but I'll tell you right now the answer is x minus 4 and x plus 2. -4, positive 2. Multiply to -8, -4, positive 2. Add to -2. After you set it equal to 0 and factor it, you then set each factor equal to 0 and solve. And so x minus 4 is a factor. Some people like to do a T-chart to stay organized. That's a good idea. And so we have x minus 4 equals 0. And then the other factor is x plus 2 equals 0. And you solve each factor. So this first one here, how do I solve for x here? For the -4, I'm going to have to add 4 on both sides, add 4. So we get x equals 4. For this other one, for x plus 2 equals 0, we're going to -2, -2, x equals -2. So -2, positive 4. What did we just find? We just found the roots. -2, positive 4. -2, positive 4. And so, that's why they're called zeros. They have y values of 0. We set our factors equal to 0 to get them. But that's what we're actually doing here. Like for all these questions, when we factor them and solve them, what we're actually finding is where these graphs cross the x-axis, the roots, which are the x-intercepts of the functions. So that's what we're doing. It's important to remember that even though when you're doing this algebraically, maybe without a graph, Remember what you're doing. You're finding where the graph crosses the x-axis. You're finding the roots. You're finding the zeros. And so that's helpful too, because what we could do for these questions that I'll show you is, after we factor it and solve it, we could check it on a graph, type it in your calculator and see if it does cross at those spots. And so for a lot of these, you could just get the answer from the calculator, but you need to know how to show your work algebraically here. I'm going to end up skipping a couple of these. This one has a typo in it. It's actually supposed to be a negative 7x, but I'm going to skip it all together. I'm going to skip this one just in the interest of saving some time. So let's do the first one here, A. There's no GCF. Trinomial, so it's basic trinomial factoring. And we're looking, what multiplies to 12, adds to 8. In this case, it is 6, x plus 6, x plus 6, and x plus 2. 6 times 2 is 12. 6 plus 2 is 8. And when you solve them, you're going to end up with x equals negative 6 and x equals negative 2. And I should probably show that middle step. X plus 6 equals 0. X plus 2 equals 0. So factor it, set each factor to 0, and then solve those little mini equations there. And so what I'll show you in my calculator, I have this pre-typed out here. This is the x squared plus 8x plus 12. It's crossing at negative 6 and negative 2. And so that confirms our solutions, negative 6 and negative 2. All right, let's try C right below. Now remember, the first step is set equal to 0. This one was done for us. This one is not. So we have to rearrange this one a little bit. We want to move this 21 to the other side. A positive 21 on the left will end up as a negative 21 because we've got a minus 21 to get it there. There's no like terms here, but you got to know the order. X squared goes first, the x to the first term goes second, and the constant, in this case the negative 21, that goes last. And now it's properly set equal to 0. Now we can factor. Again, this is a basic trinomial factoring. It's going to be x minus 7, x plus 3. They multiply negative 21, adds to negative 4. And some of you are really good at that. You can get these numbers real fast, in your head, no problem. Some of you maybe have to write off to the side. All right, what multiplies negative 21? Make all the numbers that multiply negative 21, and then find the pair that adds to negative 4. And it's okay. Take your time. Use your calculator if you need to do a little guess and check. But you got to find the right numbers. Then what we do, we set the factors equal to 0. So x minus 7 equals 0. X plus 3 equals 0, and solve. This is going to become x equals 7 and x equals negative 3. 7 and negative 3. Again, we could kind of check that over here in our calculator. This one was the minus 4x minus 21. Looks like it's crossing at negative 3, positive 7. Negative 3, positive 7. Confirmed. Below it, E, x squared minus 16, no GCF. 2 terms, minus sign, square numbers, that is a dots. So it's a difference of 2 squares factoring. And the dots are probably the easiest. We're just thinking square root, 1 with the plus in the middle, 1 with the minus, square root of 16, 4, 4. Set each factor equal to 0. Remember, if I'm going too fast for you, don't hesitate to pause the video because you want to be able to write and listen at the same time. But I think this one was probably pretty easy for you. And again, I could show you that over in Desmos, right there. X squared minus 16 crossing at negative 4, positive 4. And your graphing calculator can do the same thing. F is a challenge for some students. They see that x squared, 2 terms, they think dots. But remember, before you get to the 2, 3, 4, you got to look for GCF first. And this one has it. 2 terms, they both have an x. So you take that x away, what's in common is x plus 7 equals 0. GCF factoring, you can take away an x from both terms. And then you set each factor to 0. Now, like what we did, we set both factors equal to 0. This is a factor. That gets set equal to 0. And you're done with that one. X equals 0. 0 is one of your answers. The x plus 7 equals 0 becomes x equals negative 7 when solved. So 0 and negative 7. Again, you can confirm that over here. That's this one down here. 0 and negative 7. 0, and negative 7. So a lot of times, or I shouldn't say a lot of times, every time you have a variable GCF, like an X GCF, you're going to get a solution of 0. All right, last question. Find two consecutive integers since their product equals 20. So this is a little bit of a word problem. And again, some review material. We've talked about consecutive integers before, so you might have to go back and watch that video. But what we do is we always let the first one equal x. And then the second one, in this case, it's x plus 1 because they're just consecutive integers. If it were consecutive even or consecutive odd, we would call the second one x plus 2 because even and odd integers are each 2 away from each other. And then we got to translate this, such as the product equals 20. Product means multiply. So these things multiply to 20. So we'd write that as x times x plus 1, and their product is 20. And when you multiply this out, you're going to get x squared plus x, right? X times 1, distribute, equals 20. Now we're doing what we did above. Set it equal to 0. X squared plus x minus 20 equals 0. Factor it. X plus 5, x minus 4, solve it. X plus 5 equals 0, x minus 4 equals 0. End up with x equals negative 5, x equals positive 4. Now this should probably say find two consecutive positive or two consecutive negative. Let's go with the positives here because the directions aren't clear. So we'll go with the 4. So x is 4, x plus 1 would be 5. And so those are two consecutive integers whose product is 20. And again, you could type this into your calculator and check it if you'd like. All right, that's it. So that's solving factorable quadratics. Now let me just see if I could find the recorder to turn this thing off. I'll see you later.